Okay, great. So today we're going to be talking about particularly the data layer of blockchain and Web3. And we're going to be talking a lot about the Graph, which is one of the companies that I work for. We're going to be talking about Scaffold-ETH extensions. So Scaffold-ETH extensions are a way for you to take Scaffold-ETH and then extend it with some other added functionality. So it's very powerful because you can basically spin up an entire environment like you normally would with Scaffold-ETH, but you can also add an additional package or a mono repo to that existing package, or maybe even some modifications to the existing packages like your chain and your front end. So we're going to be utilizing the Subgraph extension system. And yeah, let me go ahead and share my screen here. And let's just kind of talk here really quick about what we've done so far really quickly. So everyone probably should have this Notion page that I've created. You can scroll all the way down and you can see the sections in the navigation. So we've covered how to build on Ethereum from a very high level perspective, talked about Scaffold-ETH. We've covered the EVM and some basics of Solidity. Last week, we talked about smart contracts themselves and standards, I guess, smart contract standards. And then today is going to be all about data indexing and why you need it and what the graph is. So we're going to talk about what the graph is and what kind of problem it really solves. And then we're going to actually try to deploy a subgraph using what a subgraph is basically like an API using the graph that stores data for your application. So you can think of it kind of like you have a SQL database. The graph utilizes SQL to create an API that is available over GraphQL. So we're going to talk about that, and then we'll cover the section for the homework. So if we click that, it's going to take you here. There's this one caveat to following along is that up to this point, we've only been using Node.js. And we've been using Git and Yarn Package Manager, but now we're actually going to utilize Docker as well. So we're going to need to kind of like virtualize the graph. The graph is a decentralized network. So there's a bunch of indexers that are participating in the network by running a stack of software. And we need to kind of simulate that on our local machine so we can do that really easily with Docker. I'm not sure if any of you have familiar with Docker. You don't need to really truly understand how to use Docker, but it's good to understand that high level what Docker does is it just provides virtualization of the containers that hold the software that you need to emulate that kind of environment. So we'll go into more detail, but basically it's three Docker containers that are your database. So Postgres, IPFS, which is a file sharing system for Ethereum or for Web3, IPFS, interplanetary file system. And then the very last one is the graph node, which is the graph has a tool that is used to index data, and that's what it's called. It's called graph node. So it's those three things running in Docker. So anyways, TLDR is you don't need to know Docker, but you'll use it in this if you want to go through this section. And it is an extension. So it's an extension of Scaffold-ETH. So let's just talk about that real quick. So Scaffold-ETH, if you go to scaffold-eth.io, this is the new version of the website. It's looking pretty good. You go to the doc section, and you come down here to the bottom, there's a section called extensions. And there's two parts. There's how to install extensions and how to create your own extensions. So if you want to take Scaffold-ETH, how it comes out of the box, and put something on top of it, you probably want to create an extension for it. Or you want to just use an existing extension that already exists. So there's a whole bunch of extensions that are available. Let's see. So if we click how to install extensions, it will tell you how to do this. So essentially you can either use a GitHub repo like this by using the -e with the GitHub repo, or you can just do -e and use a known extension. So if you look on the website for Scaffold-ETH here, there's a list of all the extensions. So scaffold-eth.io/extensions. And you can see the very, very first one is a subgraph. So this is the graph running inside of a virtualized environment. So we'll get to that in a little bit, but we're going to use those extensions. So let's start by talking about the graph. I think that's probably the most important part from this session that you're going to take away is like why you actually need the graph. So let's kind of go through it. And by the way, this is a small enough group here that we could probably answer questions. So please be sure to fire off questions if you have them. Okay. Okay. So the graph got started as a very niche use case that was kind of missing when it comes to data. Yeah, can you hear me?
Can you wait 5 seconds? I need to take a paper and pen. I only have the laptop in here. It helps me to write 2 seconds.
Okay, cool. That'll give me a chance to take a drink of water here.
All prepared, paper and pen.
I thought I was the only one who still uses paper and pen, but I use it all the time. It's like I have to have something to jot down notes. I feel old when I do that, but I feel like it's still the best way to learn.
Hey, back. Yeah.
Great. Okay, cool.
Yeah, basically, I like to draw sometimes and like my imagination and have a lot of ideas, which on paper it's easier to like create a graph of information that is needed.
That's awesome. Yeah. I love that. That's really cool. Yeah. Yeah. There's okay, cool. Awesome. Well, we'll get right into it. Okay. So again, the graph was created as this kind of very niche problem that was going on, and particularly when building a dApp or a decentralized application. And so, yeah, my name is Kevin. You guys know me already if you've seen these already. So we're going to talk about what the graph is, why you need it. We're going to talk about how to configure it and what the architecture looks like. And then we're going to try to run through and do a demo. We'll probably try to do all the steps for the workshop and then go from there. So first of all, why do we need data indexing? We already have data inside of our smart contract, right? We can already query the blockchain by making what's called a JSON RPC call, which is just an API that is available on our node. So if you're running an Ethereum node at your house and you have all of the data from the blockchain, you can query that directly to get what you want. Or you can query a provider's API like Alchemy or Infura or DRPC. There's a lot of different ones. But why do you need to index that data if you can just query those other ones? Well, the simple answer is that the RPC is somewhat complicated. You can't really get the data you need easily. So if we think of like a simple NFT contract, this is an NFT, which is very popular, known as CryptoPunks, which is just these little kind of overpriced JPEGs that people pay to basically transfer around. And these are simple in the fact that they just have an ID from 0 to 10,000. And then all that the smart contract really does is keeps track of who owns that particular CryptoPunk. And then there's another field, which is the metadata URI. So it is an ERC 721. So you have this link to where the off-chain data is. Most of the data for it is off-chain, but we care about who owns the punk because that's what holds the value. So if we want to index this data, or let's say we wanted to know who owned punk number 0 from the very genesis time that it was deployed, so the very first time. It's very hard to get that. You need to know exactly what block that the contract was deployed at, who was awarded that CryptoPunk at the time by looking through the transfers. So you almost have to make a few calls to get that information. And that's just for one punk. If you want to know, like, let's say 100 punks, you need to make 100 queries to get that data. You can't make one simple query to get all the data you need. It's just not possible with the JSON RPC. So people propose transactions for a smart contract, right? You have the data in there. If I want to transfer a CryptoPunk or if I want to sell a CryptoPunk, I'm going to make some kind of transaction to put it onto an exchange, right? So I might post a transaction. And then when that transaction happens, if you're a good smart contract developer, you probably emit an event. So you emit some kind of like data that says, hey, I took this CryptoPunk, I sold it to my friend for this much ETH, and this is his address. And at some point in time, that gets emitted as an event on the blockchains. So what we want to do is take those events And we want to take those transitions of state. So we've talked a lot about how the blockchain works. It's a transition of state. It's a state machine. And we want to track all that stuff, okay? So here's where the problems come in. First of all, there's a lot going on in a given block on a blockchain. There's lots of protocols in there. There's lots of addresses. It's hard to identify who an address is owned by unless you have their like ENS name and they're doing first lookups. And, you know, there's just a lot of complications when it comes to sifting through the data. It's very complicated. Also, like I said before, is the original idea was to create a dApp where you had a user interface that was like HTML, CSS, JavaScript, and you read and write from the blockchain. So you propose transactions to update the blockchain smart contract or the state, and then you read that data from directly from the blockchain. But when it comes down,
Hello?
Oh, I can't hear him either.
for blockchains.
Okay.
Oh, he's back.
Sorry, did I cut out? My internet's
Yeah, no problem.
I'm here at the
problem.
hotel, so apologies if I cut out again. I'm sorry. So basically, I'll rewind a little bit. So essentially, the blockchains are incentivized for writing, right? You pay gas to update state on your blockchain. But when it comes to reading data, you don't pay anything. It's free. So there's no incentive for the RPC or the node to give you that data in a quick and reliable way. So also we have this history of this problem with provenance. Like, how do we go back in time and see what happened on that contract? Like, who owned the punk at a particular time? So what we want to do is create like something like this, which is if you guys have ever heard of time machine. So it's that concept where you can go back in time and see what happened to a particular file. Same thing. That's why we need indexing, is to look back in time and see what happened with the data on the blockchain. This is a real use case or a real user where they wanted to get all the NFTs owned in a particular wallet. And you can see how this got really messy really quickly, where we had to kind of loop through and get access to all of the wallets, basically balance, and then loop through that and get a copy of what the token is that they own. So this is fine if you only have a few NFTs in your wallet, but if you were to have hundreds, this could take 10, 20, 30 seconds or whatever to load all of your NFTs into your front end. So it's very messy code. As you can see, it's effective, but it just is going to be very slow. So this is where the graph comes in, right? The graph is a replacement for the data layer, right? It's an indexing protocol. It's a decentralized indexing protocol, which means that it is decentralized in the sense that the data is decentralized between all of the indexers. There's over 200 indexers that are storing data for the blockchain or for APIs called subgraphs. There's over 100,000 delegators, which provide stake to the network for security. There's about 10,000 curators and subgraph developers that have developed subgraphs on the network all across the globe. So we want to take this mess of kind of a sea of mess and create these buckets, what we call subgraphs. So it's a way to organize the data in APIs. So essentially each particular protocol has a subgraph or a set of subgraphs maybe that kind of correlate that data and store it and make it available in a GraphQL API. So what we're left with is something like this, where we can use GraphQL. So in that other example, here where we had to loop through and get the all the balance of the address, and then get all the NFTs and tokens that they have, and then promise those all together in one particular object. We can replace that with just a GraphQL query that's like this. We can do one query, and it's a one HTTP request to get all of the data we care about. So it's very effective. GraphQL is like a front-end query language. It's very effective for getting lots of data or complex queries of data. And so we can basically say, all right, well, we want to know who owns all the NFTs in this wallet by their address, which is a string. and we're going to get the response of who that owner is, how many NFTs they have, what the IDs are, their token IDs, what the metadata is, who owned those, and who owned those NFTs as well, who previously owned those. So it's an added kind of benefit there. So then we replace this with this. So instead of reading data from the blockchain, the graph does that, right? The graph reads the data and indexes it and stores it in a database. And then the user interface just uses GraphQL right here to query the data and get that data. Okay.
So basically metadata, this whole graph just keeps some basic information for it. No, I understood. Yeah. Yeah, it's okay. You can go.
Yep. Yeah, no problem. Yeah, for sure. Okay. So the configuration for a subgraph is basically 3 files. So there's other files, but the core configuration that you need to make changes to kind of like make a very unique subgraph is these 3 files. So, or at least a basic implementation is these 3 files. So a manifest is the subgraph.yaml file. It's kind of like the high-level config file. Just like you have a config file for any software, the graph uses a subgraph.yaml. It keeps track of what network you want to query. It keeps track of what address that you want to query. So a smart contracts address keeps track of all of the schema entities in the schema. So like how you want to store the data, which we'll get to in a sec, which is this next file. Keeps track of all the handlers on how you want to process the data. So this kind of like links these together. So you can think of this as the high-level config file. The entities are how you store the data and how you expose that data. So in other words, if you have a smart contract that emits an address every time someone transfers an NFT or a token, well, it's going to probably emit an address, and it's going to emit an unsigned integer, which is the token ID, and it might have some other information as well. But the entity is exactly that. It's like what kind of data types are coming off of the events, and how should they be exposed over GraphQL? So if you've ever used GraphQL, it's this GraphQL configuration file. It's kind of like how the data should be structured. And then the very last thing is the handlers. So the way the graph works is it's a WASM system, or it uses WASM. WebAssembly is basically like kind of an optimized, fully encapsulated, very secure way to do some kind of processing on the web. So WebAssembly, and we use assembly script to do all of our processing. Assembly script is very similar to TypeScript. It's actually a subset of TypeScript. So what that means is it looks like TypeScript, but it doesn't have all the full functionality of what TypeScript offers. But you can you can use some packages that are available that we have, like the GraphTS package. And if you've ever written TypeScript, you probably can move around pretty easily with assembly script. And that's how you actually process the data. So as the data comes off of the events, this WASM module is always running, and it's kind of like deciding what needs to happen with the data and how it should store it in the entities. So it does all the processing and the saving and the loading of the data and manipulation. If you want to like change things or do any kind of like mathematical calculations, you do that inside of the assembly script. And that assembly script is compiled down into a WASM module. So you write it and you build it and you deploy it to the network as a module. We'll get deeper in this in a little bit. So events come off the blockchain. The WASM module essentially processes that data and stores it in a database, right? So this is what the graph looks like. It's basically a database, and it is a storage of configurations and WASM files, and it's all of the data sitting in there and exposed using Graph Node. So Graph Node is kind of like the main binary for the graph that does all the heavy lifting on how to get the data from the database. So if a user comes through and wants to query for a specific set of data, they just need to make a GraphQL request here with the data that they care about, or the request that they care about. The graph node will go back to the database that's on the indexer, and it will query using SQL to get the data it needs. And then it will create a response in GraphQL. So it's kind of like a middleware, or like a middle layer between that database of blockchain data and the end user, which is the consumer, which is usually a web application, right? Like a front-end web application. I'm going to pause there just for a second and see if anyone has questions. And if I'm going a little fast,
Pretty clear.
Oh,
Pretty
yeah,
clear
go
with
ahead.
me.
Clear?
No,
Okay.
it's just saying it's pretty clear. It's pretty
Okay.
intuitive until now, and yeah.
Cool. Okay. So this is kind of a high level overview of what we're trying to do, right? Today we're gonna build a dApp using Scaffold-ETH. We're still gonna propose transactions to the blockchain to write to our smart contract. But as the events come off of the smart contract, Graph node is going to be running the WASM module, which is here, and it's going to be processing the event data as it comes off, given the instructions in that module. It's going to store that stuff in a Postgres database in the backend. You won't even ever see that, and it will expose it over GraphQL in an API. So you'll have this new API, and we will just query that GraphQL API directly. Instead of having to go through the blockchain to get the data we care about, we'll just use the GraphQL API. Okay. I'm going to skip that. You don't need to know that. Okay, so Scaffold-ETH, again, there's an extension. I've already talked about it, but it's the most popular extension I would probably with Scaffold-ETH, or at least one of. And again, it's just going to replace and add an additional repo called the Subgraph extension.
You guys are not hearing Kevin again, right?
No.
I was about to unmute myself. Yeah.
Chat, there's a graph.
Like 10 seconds. Again, like
Sorry.
10 seconds. We lost you for some 10 seconds. We just repeated the last slide.
Yeah, sorry, the hotel's really bad internet. Yeah, cool. So it's create extension -e subgraph is going to give you that extension. We're going to use that. And then this is just the Graph's official Telegram. If you want to join the Graph Builders Telegram, you guys can join this if you want. But we're going to use the Discord for everything anyway, so don't worry about this one. Cool. All right, let's do it. We're going to actually do something. So let's actually, how much time do we got? Oh, nice. We got like 20 minutes. We'll leave 10 minutes for questions and stuff like that. But let's just try to build something out. Okay, we're going to use, just like I always do, we're going to do npx create-eth at latest and -e subgraph. So we're just going to add this extension. It's going to ask us if we want to go out and install the package if we haven't done it, but we already have it. It's going to ask us what we want to name it. We'll go ahead and name it the graph. Yeah, sure. And then we're going to say what chain we want to use. Just like before, we can choose whatever we want. I'm going to choose hardhat. I always choose hardhat. Foundry is okay, but you need to install Foundry and all this stuff. So, and for the sake of the little learning, I would say let's just all keep it on hardhat if we can, unless you're really die-hard Foundry fan. Let's see how long this takes. So while this is kind of doing that, let's come back in a little bit. Let's look at Scaffold-ETH docs again. And actually, no, I'm sorry. Let's go to the GitHub. So if we go to the build guild GitHub, or sorry, the Scaffold-ETH GitHub, click here. There is a Scaffold-ETH extensions, create-eth extensions. So you go to repositories, create-eth extensions right here. So this is the extension system. And if you click on the branches, we can see all the subgraph, all of the extensions. So we're going to be using the subgraph one. So we click view all. Oh, they move these? Oh, there it is, subgraph. Cool. So there's the subgraph one. Okay, so there's a README that walks through all this stuff that we're going to do. So if you guys get stuck, it's also in the Notion, so don't worry about it. You can just go there. But the main differences between this through the regular Scaffold-ETH is that there's another folder that we add. We add this new folder, and it's called the subgraph folder. So if you go to packages, you'll have this new subgraph folder. So it's going to be called subgraph. Still installing. Okay, so the subgraph folder is going to have those 3 files I talked about in it. It's going to have the subgraph YAML, which is here, which is the config file. It's going to have the handlers and the schema inside of the source folder right here. Okay, so it's going to have the mappings.ts, which is TypeScript, but it's assembly script, and the schema.graphql, which is the GraphQL schema. We're going to look at those files in a sec. I don't want to get too into the weeds, but the file I want to show you is in the graph node folder, as well as how we're going to spin up the graph. So we're going to spin up the graph using Docker. So there's a Docker compose file here. So you don't need to understand Docker, but I want to just kind of cover it basically. Docker compose allows you to spin up a container for every service that you want to have. So we're going to have one for graph node, which is the workhorse on how to run the WASM modules and query the blockchain. And then we're also going to have one for IPFS, which is the interplanetary file system, which is where we store like the manifest files and the WASM module. And then we have one for the database. So that's Postgres. So when we load up Docker Compose, it's going to load all this stuff for us and virtualize the Ethereum stack, or basically the indexer stack. So now it's ready to go. So let's do this. Let's go through and just do our normal thing. So we're going to go yarn chain to spin up our chain, right? Oh, sorry, we need to go into that folder. Yarn chain to spin up our chain. I'm going to spin up my other windows like I always do. So I'm going to go into this window over here. So I have this one's going to be our chain. This one's going to be our front end. So let's do yarn start. And then this other one, now we're going to need, we've been doing the 3 window thing, right? Chain, front end, deploying here. We're going to need one more window because now we need to use Docker. So we're going to open up another one here. And we're going to go into the same folder, and we're going to do yarn run -node. So this is a new command, right? This is going to spin up the infrastructure that we need to run in Docker. So it's going to tell us Docker is not running. So if you don't have Docker running, you need to start it. So Docker runs as like on your machine. It's kind of like a virtualized kind of tool. So you need to install what's called Docker Desktop. That's in the instructions. For this Notion that I show off, but Docker Desktop is just going to allow us to do these virtualizations. So it's starting up right now. Let's give it a second. Well, while it's doing that, let me do a deploy. Let's just see if our oh, sorry, I got to go into the folder. Yarn deploy. Okay, should deploy successfully. Let's see. It's a little slow. Yes. It's working. Now let's see. Let's just make sure Scaffold-ETH is up too as well. And Docker should be up now. Let's take a look. Yeah, Docker's up. So you know Docker's running when it's like green up here. So it says Docker Desktop is running. Okay. So we're loading up Scaffold-ETH right now. Oh, what's that? Okay. I might need to fix something here. There might be a problem with the extension right now. Let's see if I can fix it. Packages, Next.js. What is it? What's it complaining about? It's complaining about the Apollo client and Scaffold-ETH providers. Okay. So if we go to app, components, sorry, there's an issue here that I need to probably fix. What is it complaining about? Apollo client. Here we go. Here. It's complaining about this. I need to get rid of it. I should have done this a while ago. So we used to use Apollo client, but we don't anymore. So it's complaining because the package is no longer available. So let's save that. I'll fix that later. Okay, now it's working. Okay. So basically what was going on, this is fun. Let's figure out what I just did. So there was an error talking about Apollo client. It was basically saying that my Apollo client was trying to load, but it wasn't installed. So I just basically found out inside VS Code like where the error was. So I knew it was in the Scaffold-ETH app with providers. So the way Apollo works is it's a GraphQL query tool. It allows you to query data from GraphQL and display it in your front end. We don't use Apollo anymore. We use a tool called Graph Client, which I probably won't talk about much today, but maybe we'll do it in like future sessions. And so I just needed to fix this by removing this import because it's no longer found. And then once I did that, I also didn't have a way to do the subgraph query by creating the Apollo client here. So I had to remove those things because I don't need those anymore. And then I also had to undo the wrapper, which is basically you wrap your application in the provider, and that's how you get the data you need. But we don't need to use that anymore, so I just removed that. So that's a good little kind of learning tool on like how Scaffold-ETH works. But yeah, again, we don't use Apollo anymore, so that's how I fixed that. So anyways, it should be good now. We have Scaffold-ETH up and running. Now, what you'll notice with this new version is we have this subgraph tab now. So this subgraph tab is basically like an extra folder inside Next.js, and it walks you through how to set up the subgraph extension. So yarn run node was the first thing I had typed, right? So let's come over here and let's try it again. Yarn run node. So what this is going to do is it's going to run Docker compose up, okay? So we can see here that now it's loading up the Docker containers. So again, there's 3 of them. It's Graph Node, IPFS, and Postgres. Okay. So these are loading. This might take, like, depending on your computer, it might take like a couple minutes to load. You know that it's working and ready to go when you get a message that says waiting. What does it say? Oh, downloading latest blocks from Ethereum. So it's ready basically now. So basically it's saying, okay, well, we're ready to start indexing data. So I'm going to go out to the blockchain and try to get those. It's pointing at our local blockchain. So it's not pointing at like Ethereum. And that's why you see up here, we started to get all these calls. So now everything's up. We're up and running actually. We haven't deployed a subgraph yet, but we have the ability to. Everything's running in Docker, and we also have Scaffold-ETH up and running like we have been in the past. But let's take a look really quickly at the subgraph. So this gets a little more complicated, so I'm going to try to go slowly, but at least explain it. Inside this, there's a new folder called subgraph. And inside there, again, is the 3 files. So the subgraph YAML, and in the source file, the schema and the mappings, the handler. So first of all, the subgraph YAML, again, it's a high-level config file that keeps track of what network you're on. So in this case, localhost, what the address of the smart contract is that you want to index, right? And what the entities are, how you're going to store that data inside the graph and expose it with GraphQL. And then the handlers is how you want to process the data. It also has a reference to where the ABI is. We haven't talked much about the ABI on these series, but the ABI is kind of like the high-level map to your smart contract. And it makes your smart contract more human readable. And the graph needs that because the graph needs to understand the data types that are coming off of your smart contract. So if you have events defined and stuff like that, we get those from the ABI. So we reference where that ABI is. Then we have the handler location and the schema location. So it's a config file. That's all it is. Now we go to the source file. So the source schema.graphql file essentially is saying, like, where do you want to put the data? How do you want to store it? So in this case, we have 2 entities. Sorry, my throat's like bothering me a little bit. Okay, so there's two ways that we want to store data in this case. This particular extension comes with a starting subgraph that matches the Scaffold-ETH contract. So you guys all know the Scaffold-ETH contract. It's like the debug contracts tab, and you have this kind of like unstoppable apps greeting, and you might want to update it, right? So you come up here and you get some funds from the blockchain right here, and you say like, well, what is the greeting? Well, I want to change it to Pupin's challenge like this, right? And I want to hit send, right? It just allows me to update the greeting, right? Well, there's a smart contract that is already written for that inside of the hard hat folder. And it has the contract, and it has a year contract, and it has an event. So it has an event right here that gets emitted. So it has an address, which is who set the greeting. It has a string, what the greeting was. It has a Boolean, whether the premium was paid, so true or false. And it has the unsigned integer value, which is like how much money was paid in the value of the transaction. And we emit that here at the bottom of our function. So just like any application, you should have an event that updates whatever you care about there. So just like that, we also have a subgraph that's already written for us. So in this case, we want to keep track of all the greetings that happen. So if someone sends a greeting, like I just wrote that greeting, that's a greeting. But then we also want to keep track of who sent the greeting. So I am the sender. So there's another entity. So these are actual like database entries. So one called greeting, one called sender. And then we do this interesting thing where we like link them together by using a cool feature called derived from, where we can take one entity and sync it with another one up here like this. So these are kind of like linked together, which is really cool because it's optimized in the back end and handled in the back end. So anyways, this is how we store the data. All the data types are here. The things that are unique are the IDs. IDs are like how the unique identifier is stored for the graph. The best way to do it is with bytes. Here we're using like a unique ID. I won't get into that too much today, but those are the IDs. Then we have the data types. In this case, we have this more complex one where we're doing like an array, well, a virtual array, and storing those with the derived from. But then we have these other ones, which are like the greeting, which is a string, and the premium, which is a Boolean, and the value, which is a big integer. And then these things come from the blockchain themselves when it was created. So the actual timestamp, what the transaction hash was, right? Those come from the blockchain. Same thing right here as well. Greeting count is an interesting one here as well. This is an added one that we're gonna keep track of. But then the handlers, this is where it gets a little more confusing, and you guys are gonna like maybe glaze over a little bit, but that's okay. You don't need to understand it 100% right now. But again, it's how we process the data. So the handler that's its whole job, is to take in the data as it comes off the event like this, do something with it, whatever you define. So you define like how you want to handle the data. So just like any TypeScript application, you have the types that you can import. So the benefit to types is you can like interact with them and have all of the types built. We're getting errors about the types. That's because we haven't generated them. We'll do it in a second, but we need to generate these types. It makes it a lot easier when you're writing an assembly script, because then you have the types to work with inside of your code, and your editor will kind of help prompt you on what you need to add. But what we do is we say, okay, let's take in an event called greeting change. Every time that event comes off, run this handler, like handle the data, right? And we create a string of what the event ID should be. We try to load that string. If we can't load it, if it's not found, if it's null, then we create a new sender. So this is kind of like where we do a check. We say like, all right, well, let's figure out what the ID should be for that sender. Try to load it. If we can't find it, create a new one. So we do the new here. And then we set who it was, what the address was, we set when it was created, what the greeting count was, we set it to 1. So we do something where we like use a big int from my 32.1, which is just 1, to set the greeting count to 1. So we do some like math in here, which is really cool because this is off-chain stuff, right? We're using the graph to do off-chain data indexing, but while we're doing it, we can do some other things, right? So here we can like do some calculations. Like here, we say, well, if they've already set a greeting one time, well, next time they send in one, let's increment it by using the .plus command, right? Or .plus functions. So we're doing some like math, right? Obviously, you can do more complicated things. This is just keeping track of how many times a user set the greeting. Then we do the same thing for the greeting. We try to create a new greeting. We always know it's going to be a new greeting because every function call to that transaction set greeting is a new greeting. So we don't need to check to see if the greeting has already been used before. We just want to go ahead and always assume that it's a new one. And then we do the same thing. We set who the greeting is or what the greeting is, who sent it, whether they paid a premium, what was the value in the transaction if they sent any ETH, what was the timestamp. This comes from so a lot of these come from the event parameters. Some of them come from the event block data. So this is actually like the timestamp coming from the Ethereum block. Same with the transaction hash. And then we do some stuff like using 2hex and 2string, and there's some conversions that happen. But at the very end, we just save the data. So these two commands actually save the data in the database. The minute it's saved in the database, the graph knows how to handle the data. It knows how to give you a query. So let's do it. Let's take this subgraph that is, we don't even need to touch anything. It's ready to go. And let's deploy it, okay? So we know the graph is running. We have our blockchain. We have everything going. Let's do yarn local create. It's going to spin up a block. It's going to spin up a Scaffold-ETH your contract subgraph, which is like a way to look at the data. It gives you a graph IQL interface. So we just need to do that once. Then we can do yarn local -ship, I think. Let's see. There we go. Now it's basically going through and compiling. It's generating the types. It's making sure that there's no errors. And now it wants to deploy it. So it's going to ask you what version that you want to deploy. So just like any versioning for any software, you just decide what version you want to define it as. So we can just do 0.0.1, sure. So now it's going to compile it again, make sure there's no errors, and deploy it for us. So if it's going to give us this URL right here. So it gives us this like subgraph URL. So if I come over here and load it up, it's a graph IQL interface window, which is what we deployed earlier when we did that yarn local create. And there's this Explorer tab right here. And we can look at the data. So what's really cool about this is we can say like, all right, well, let's let me make this a little easier to read. Okay, so let's look at all the greetings. The first, however many we want, like 10, order them by the timestamp when they were created, change them from ascending to descending or whatever we want. We can order how we want to order it. Get what the greeting is, when it was created, what the ID was there a premium paid? And then we can say the sender, who was the sender and what was their address? And then we can play. And there we go. We get the data back. So we get the data. It's an array of greetings. There's only one because I made it. It's Pupin's challenge. It was created at this timestamp. Here's the ID. And this is the address that set it. So it's this address. So 0x7b31. So if I go to Scaffold-ETH, 0x7b31, that's me, right? So if I come over here and say, let's do hello and just send a bunch, boom, 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 I send a bunch, come over here, hit play, there they are. They just come in. So the graph is indexing that data. And so when I'm hitting play here, I'm using an HTTP query to just get the data that I care about. So if I want like the first 100, I could grab the first 100. And I could literally come here and just spam, like I'll just send a bunch here. And now I go over here and hit play, and I'll get all that data here, right, in one query. As opposed to in the past, I would have to loop through, and get all the data I care about, right? I can just do one simple query. And I can change it. Like if I don't care about the premium anymore, and I don't care about when it was created, I just want to know the greeting. Matter of fact, I don't even care who sent it. Just tell me what the greetings were. Like, boom, there we go. I get all the greetings. So it's very like customizable, like how you query the data, what kind of data you want to get, how you want to just, process the data. The last thing I'll mention real quick is in the front end, there's that subgraph folder here. So subgraph tab. If we go down to the bottom, there's a table here. that gets all the data in a nice, pretty displayed table. So it's only doing the first 25. But if we go to the code and we look at Next.js, so we use Graph Client and let's see, where's it at? There's a graph client RC, which points to our subgraph, what the name of it is, and then it points to where the query is. So we use this .graphql structure. So it's here, and it's get readings.gql. So we do the first 25. I could change this to like 30. Let's just change it to 30 and save. Now it's not going to show up right away. We need to like build out the query. So we can do that with the Yarn Graph Clients build, I think, something like that. Let's see if that works. So I made a change to my GraphQL, and I need to refresh here. There we go. Now we get 28. So now we can see there was 28 events that were marked off. So interesting, but we basically made one little change to our GraphQL query, and then we just rebuilt the artifacts. These are like graph. So we use Graph Client, which is like how we display the stuff. We might put that back to Apollo, but I don't know. Graph Client's nice. It's just a little more complicated, but that's how we display the data. You could use Apollo. You don't need to use Graph Client. You could replace it with Apollo. And there's also other Apollo or the other GraphQL query you can use. Okay. Cool. So I know this is probably a complicated episode for a lot of people. You guys are gonna have to go back and replay this probably a little bit. But I would recommend that you go through and do what I just did. So let's take a look real quick at the steps. They're all should be in here. So we just do the normal Scaffold-ETH stuff. This is how you spin up the environment. It's how you deploy. This is how you deploy your subgraph. That gives you the query, and it shows you how you should get the data back. So it's pretty easy. And then I also talk about how to build the artifacts if you want to change those. And I show you how to like get the data and look in there. So the homework for you guys is to go through what I just did on your own. Expand here for extra credit. It's just a fun little thing. And then the last thing is maybe deploy a subgraph to the Subgraph Studio. So I didn't talk much about, we've been doing everything local, but if you go to the graph.com, if you want to then take this data, new website. This is new. First time I've seen it. If you go to products here, there's two products that we have, the Studio and the Explorer. The Studio is where if you're going to create a subgraph, the Explorer is where if you want to find one that's already created. So if you're a developer and you're building a DeFi tool, right? Well, you probably want Uniswap. So you could come down here. There's a Uniswap subgraph. There's also one for AirSwap, Snapshot, if you're into DAOs. There's a bunch of subgraphs. There's 10,000 subgraphs to be exact. So you might already find one that's already available. And so like, you go to Uniswap and you can see here the same thing. You can query and get the data you want and see what it looks like. Then you can go to About, and you can get the information about the subgraph. But if you want to query it, this is the subgraph, and all the information to query it is down below. But if you want to create a subgraph, you go to Subgraphs, go to Subgraph Studio, and you can create one and deploy one on your onto the network. So you can actually put it onto the network in a sense. So you can connect your wallet like you normally would with any app, and in here, and connect. You have to sign a message to confirm that you own the wallet, and you can sign up. So I can put whatever. So you want to sign up for the newsletter now? Okay, this is silly. I think I'm in the wrong wallet. That's why. But anyways, you need to like put in your thing. We can connect to this one here. There we go. Okay. So you can see I've deployed a lot of subgraphs. So you can come here and say create a subgraph. excuse me, and then you name it. So like hello. Hello, you can't do special characters, so I guess underscore works. There's hello, and then you can deploy the subgraph. So if you want to learn how to do it the easy way, this is the easy way. All the steps are here in the subgraph. It tells you exactly how to deploy it. So you can point your subgraph at any smart contract and it will create one for you. So if you want to use like CryptoPunks or like any kind of NFT contract is a good one to learn, or any kind of popular contract. That's extra credit if you go through and do that as well. Okay, cool. So I talked a little bit longer than I wanted to. I want to leave time for questions, but as always, I talk too much. But yeah, maybe we have time for like 1 or 2 questions.
Aline, Sebastian.
Yes. I was watching. Aline, do you have any questions?
No, I don't. That's pretty
Basically,
straightforward.
yeah. I mean, it's fun. I'm eager to do it, try it, and yeah, see if I have some issues.
Cool, no problem at all. Yeah. You're on mute, Vladislav.
Yeah. Now it becomes more and more interesting. Like you never talk too much. Like it's always something new. Like to play.
Yeah.
Yes.
And again,
Cool.
we have to listen the whole session. Like a couple of parts, I was like writing down. Like, okay, I need to listen to this again.
Yeah. Well, I'll get the recording to you, and then that way you guys can repost it. And yeah, I'll be trying to monitor the Discord channel as well. So thank you, everyone.
Cool. Excellent stuff. Thank you, Kevin.
Thank you,
all.
Kevin.
Thanks.
Cool.
Great.
All right.
Great
You guys have a good
presentation.
rest of your night. Yeah, of course. All right.
Yeah,
See you
you
guys.
See ya.
Good night.
See you. Bye-bye.
Bye-bye.